In this video, we'll look at probability distributions. So our first definition is a random variable is typically treated by x as a single numerical value determined by chance for each outcome. That's what we'll define as a random variable. A probability distribution is a description that gives the probability for each value of that random variable. It is often expressed in the form of a table, formula, or graph. We usually have a table here. So we have two kinds. There's a discrete and a continuous. Discrete is a collection of values that are finite or countable. You can count them, like number of flips of a coin. If there are infinite many values, the number of values is countable if it is possible to count them individually. A continuous random variable has infinitely many values, and the collection of values is not countable. So for example, if we look down here, a probability distribution that's discrete will just have like the first one, the second one, the third one, and their probability associated with it. But with a continuous variable, there are many items in between, like the length of a pencil, right? There would be a whole bunch of different pencils in different lengths, and then they would be all in between. It wouldn't be just one length. And then there'd be a probability of getting that length. To have a probability distribution, we have some requirements here. There is a numerical, not categorical variable, and its number of values are associated with corresponding probabilities. So getting one of these things has to correspond to a probability. The sum of the probabilities, that's what that says, is equal to 1. You add up all the probabilities and it equals 1. If you're adding it with the rounded values, they might get close to 1, and that's acceptable because of the rounding errors. Each of the probabilities obviously has to be between 0 and 1 for each of the individual random variable x's. The second requirement comes from the simple fact that the random variable x represents all possible events in the entire sample space. So we are certain that with a probability of 1, that one of the events will occur. The third requirement comes from the basic principle that any probability value must be 0 or 1, or have a value between 0 and 1. Those are pretty basic stuff. A coin toss is a good example here. Let's consider using two coins and we toss them, and the following random variable is x. It's the number of heads when you toss two coins together. Above is a random variable because there's numerical values dependent on chance, right? With two coins tossed, the number of heads could be 0, 1, or 2. And here's our table over here that shows that. Toss the two coins, you get 0, 1, or 2. And it's a probability distribution. It gives a probability for each random variable x that satisfies the three requirements as listed earlier. Variable x is numerical, associated with probabilities. The probabilities all add up to 1. Each of the probabilities are between 0 and 1. Specifically 0.25, 0.5, and 0.25. Now remember, how are we getting those probabilities? Well, remember, if you have two coins and you toss them and you look at no heads, the first one could be two tails. You could have a tail and a head and a tail, and then two heads, right? And that's what it's showing in the probability. 2, 1, 1, and 0. And so how many are there? It's 1 out of 4, or 0.25, 2 out of 4, or 0.5, and 1 out of 4, or 0.25, the probabilities of getting those items. Now the parameters are as follows. We have the mean, and the mean is just defined as this. Mu, it's the sum of all of the numerical values of what you're getting at random variable x times the probability. So, if we go back here and look, this is the x values down here, and these are the p of x values, the probability. So it's taking this value times that value. and adding it up. That's what the summation means, added up. So that's the mean. Just multiply those together and add them up. The variance and is a little bit more complicated, but then you have the standard deviation, which is just the square root of the variance. They use this one here. A little bit more easier to calculate. So we'll look at the square root. We'll look at the mean and then the standard deviation. The expected value is just the mean of the probability distribution. So the mean of the discrete random variable x is the theoretical mean outcome for the infinitely many trials. So it's the theoretical, is what it should go to. We can think of the mean as the expected value, in the sense that is the average value of what you expect to get if the trials could continue indefinitely. So if you were to keep flipping a coin, you would get whatever the expected value is, whatever the mean is. So there's the definition. Expected value of discrete random variable x is denoted by E and is the mean value of the outcomes. So it can be found by evaluating this right here. And I'll show you how to do that. Here it is in the picture, and I'll show you how to do it in Excel and statcrunch. But basically we took our table and we wrote it out. 0, 1, 2, and their probabilities. And it's pretty easy. You can use a calculator, and it's a small amount here, so it makes sense. You just take 0 times 0.25 and then get your answer. 1 times 0.5, 2 times 0.25 and get your answer, and then add them up. The expected value is 1. 1 head. If you continue flipping 2 coins, because it's in the middle, it's the one that comes up the most, right? It makes sense that you get 1 head. Let's look at Excel. Here's my information. If I wanted to create a little formula for that, I have it already set up. I just copy the information and put an equal sign and take this box times the 0.25 and then just take the quarter, pull it down, and then take this one and write equals sum and add them up. Now that way it'll work for all types, for bigger, big data sets and small data sets. So 1 would be the mean. Okay. The next one we'll be looking at the standard deviation. It's a bit more cumbersome, and I'll show it to you here. You'll have to find the expected value like we did, and then you'll have to, in the homework, but then you'll have to do a few more things to it. I have a video on how to do this in statcrunch. So we can just do this quickly in statcrunch, but I want to explain to you how it comes out. So here's our information with heads and tails. You'll notice we have the mean down here. It's 1. Now look at what we do to the table. We actually use that mean in the calculation of the standard deviation. It's the x value minus the mean. Then it's the next x value minus the mean. And you're squaring that, right? So not only are you subtracting them, then you square it, and then you multiply it times the probability. That's what this says up here. X minus the mean squared times the probability. And then you get these numbers, and you add them up, and that's a variance. That's a sigma squared. So then we take the square root of it, and we'll get 0.7. I can't do that right here. Well, it's already done, but I'd rather just do it in Excel right off of what I have started, right? So here's my other box. I'll delete this one and move it over. We're just going to kind of create this. X equals, I'll put a parenthesis, equals, and then we put a parenthesis, and where's my x value? Right there, minus my mean, which is right down there, and then raised to the second power, and then multiply the p of x, and hit enter. Now I got to do a little bit of adjusting here, because I want to keep pointing to the mean, right? This one I don't want to go down. If I drag it down, this box moves down. So I want to keep pointing to it, so I'll put a dollar sign in the middle, and that will keep it pointing at that box. Now as I drag it down, you'll notice that when I look at the formula, it's still pointing to the 1, but it moved down 1. If I look at the formula in the last box, it's still pointing to the 1, but it moved these boxes down. Then I just have to add them up. That's what the formula says, so equals sum, and add them up. That's the variance. And now if I want the standard deviation, I just have to take the square root of that box. Equals square root 0.707. And if you see, that's what they have here, 0.7. So again, you have to be a little careful when constructing this, right? Make sure you know how to write the Excel formula, and make sure you're pointing at the right boxes before you pull it down. Alternatively, we can open this up in StatCrunch. I just pasted the information in here, and this is how you do any kind of probability distribution. And it's in that video, a little bit more explained. But you go to Stat, Calculator, Custom. The variable, or the values, are in X, and the weights, or probabilities, are in P of X, right? And then compute. And there we have it. The mean of 1, the standard deviation, which I just calculated as the same. And now this gives you the variable. Now you got to be careful what you're looking for. This says P less than or equal to 1. So that means it's taking 1 and 0 and adding them up. 0.5 and 0.25, right? But of getting 1 head, that was just 0.5. Of getting 2 heads, that was 0.25. Of getting no heads, I did the equals, right? 0.25. So this is showing all the probability that were for each head, right? And if you want to make less than 1, what's less than 1? Well, there's nothing less than 1. It's discrete, right? It's just 0. So that's why it's 0.25. That's different than less than or equal to 1 because that's now adding in the 1 head. So the interpretation there is when tossing 2 coins, the mean number of heads is 1, the variance is 0.5, and the standard deviation is 0.7. Also, the expected value of the number of heads when 2 coins are tossed is 1. Expected value and mean are the same, which is the same value as the mean. We are to collect data on a large number of trials with 2 coins tossed in each trial. We would expect to get 1 head. So we keep tossing and we get that. The average would be 1 head. All right, the range rule, we have seen this before. It's for identifying significant values. So in the homework problem, there's one in there that asks, is this significant or not? Or where is there significant? Well, it's 2 standard deviations above or below the mean, right? Below the mean, above the mean. Values that are not significant are between. So this includes, so it's exactly at 2 standard deviations above or below. Anything between is not. They also call this, the kind of idea here is significantly high number of successes. X successes among n trials is significantly high number of successes is if the probability is of more successes is 0.05 or less. So it's saying, hey, this doesn't happen that often, 0.05 or less. And significantly low number of successes, the trials is significantly low if the number of successes is fewer than 0.05, again, 0.05 or less. It's just saying that, hey, if you find something that's not happening often or something that is X or more not happening often, that means you're having something that might be significantly high or significantly low. Again, it's just if it's X or more, like more than 5 heads, and less than 1 head, right? It's like how many trials are you looking for? And if that probability is less than 5%, it's either significantly low or significantly high, depending on if it's above or below what you're looking for. Okay, expected value. Example, I chose this roulette one. We've been looking at that, so we'll look at it again. There are 36 numbers we know now, right? And there's 0 and 0, 0 for a total of 38 spaces on the roulette wheel. And then the ball has to land in one of them. So we have a 1 in 38 chance to win, right? So 1 out of 38 is our probability of winning, because we only get to choose one number. Let's say we choose the number 15. I bet $1. What is the expected value, or what's the mean that you'll win? What's expected? And our payout is 35 to 1. They don't give us the 38 to 1, right? They give us the 35 to 1. All right, so if you have this information, you're really supposed to create this box, right? So you want to know what you win, you want to know what you lose, and then you have your x and your probability. That's how you want to do it. So you have x and then your probability, because it's a probability distribution. So with x, these are numerical things. If you win, right, with x, it's not just a 1, 2, or 3, it's a numerical. That's where the 35 comes in, because I win $35 to my $1 I bet. If I lose, what do I lose? I just lose my $1, and it's marked with a negative sign. So I'm creating this probability distribution. It's a little different with the gambling. We're not just 1, 2, or 0 heads, right? This is $35 and lose $1. And then the probability of winning was 138, we already discussed. And then the probability of losing was 37 over 38. So here's what it looks like. And then you just, multiply the numbers across and add down for the mean. So that's what I'm showing you right here. Take the 35 and the 138, multiply them across, I get 92 cents. Take the negative 1 times the 37/38, multiply across, and we get negative 97 cents. Add them down, and then that's your expected value. So if you indefinitely bet $1 on roulette, and you continue betting all the time, you're going to come and lose 5 cents overall, just by betting $1. Obviously, the casino has an advantage, and that's their advantage, right? They're going to always take money from you. So this would be the mean or expected value. Of course, you could actually put this information into statcrunch just by putting in the numbers 35, 1/38. Maybe we can quickly do that. I'll put it right in right here. 35. So I have to put these as decimals, so 138 will be 0.0263159. 37/38 will be 0.9736841. Stat calculator custom. Variable in 6 for the values, and the weights will be in 7. Compute. There they are. And there's the expected mean, negative 0.05. Okay? So this section basically is all on probability distributions and kind of being able to calculate them and use statcrunch to find the mean, which would be the expected value. And then also looking a little bit at significantly high and significantly low, 2 standard deviations above or below the mean. And then if something is 5% or less, that means it is significantly high number of successes or a significantly low number of successes. All right, if you have any questions, please post in discussion.